and the ones from the Netherlands fall here. Okay, so these are the current, the tips are the extant locations, but we can put the derivation point for where these are across that part of the phylogenetic tree. Now, a paper that was published in Nature by a group out of McMaster University in Canada, by Bose et al., actually went in and they resequenced and completely resequenced the genome of Yersinia pestis. What they found was, in fact, it fell right there, consistent with this other study. And what was interesting was there were no SNPs, or very few SNPs, that separated it from the backbone. So in this case, it wasn't just a hypothetical branch collapse, but in fact it was a real branch collapse because this thing had been evolving for 600 years. Finally then, if we look at the 6th century of the Justinian plague, again by using canonical SNP genotyping, we find that it falls more basal, remember this is the root, more basal on the tree, so that these ancient DNA samples are in fact coming back and are consistent with the phylogenetic tree. What's important here is if we had done this analysis without having the phylogenetic tree first, we would have had zero capacity to interpret what we were seeing. So I'm going to tell you about the, how am I doing on time? 5? Okay. So I'm going to jump to my favorite, Yersinia pestis, which is in the United States. And so we have the Yersinia pestis plague all across the United States. It came in through these port cities where it then spread to the rest of the continent. And so this is where we see plague today. This is a phylogenetic tree based upon that. By doing whole genome sequences, we can look to see what the pattern is across this landscape. And what we see is, in fact, it's very complex. We don't actually see a good, clean phylogenetic pattern for the introduction from a single location across this large scale. I think that Ecuador is probably about this big right here. So this is a very large area. When we look at the phylogeny across North America, what we see is a radiation or a single point with a lot of radiation coming out. This is consistent again with a boom or a very large increase in population size, so that the bacteria comes into the United States, there's a naive and open niche, and it takes off, again, highly clonal. Now, the way I got involved in Yersinia pestis was by analyzing an outbreak of the disease that occurred literally in my backyard. I was at a birthday party and one of the other parents said, hey, all my prairie dogs, these social rodents, have died. I said, wow, I wonder if it's plague. So we went out and sampled. Actually, what I did is I went to the lab and recruited the most naive graduate student I could find. Now, this is Jessica Gerard. And so she's out sampling this prairie dog town where they had died. She's got a GPS unit there so we can go back and do math.